A2Plus versus Assembly4 in assembly and animation. Parts of the steam engine are created by this YouTuber. Create a new file. Switch to A2Plus web branch. Import parts to view. I have exported all the parts to step files, so it is the same either a FreeCAD file or a step file. The position of the first imported part is fixed and I'll change it later. Import the part main body. Right-click the mouse and select Transform. Rotate the part by 90 degrees. Select the circular edge as indicated. Select the first one, hold the Ctrl key and select the second one. Add circular edge constraint. Add the crane. Rotate it by 90 degrees. Select the circular edge at the crane and the shaft. Add circular edge constraint. Always hold the Ctrl key when select the second circular edge or constraint. Although the crane fits into the shaft, rotating the shaft will not rotate the crane. So we need to lock the crane at the shaft. Select the line at the inside surface and the line at the shaft. Apply axis coincident constraint. Remember, always hold the Ctrl key when select the second line or constraint. Move the crane adjacent to the bushing. You can edit the circular constraint to move the crane. Change the offset distance to -65. Click the Move under Constraint button. The wheel is fixed and cannot be moved. Select the wheel and change fixed position to false. Change fixed position to true for the main body. Click the Move under Constraint button. So now, move the wheel will rotate the crane. Add connecting rod to the assembly. Rotate it by 90 degrees. Select two circular edge and apply circular edge constraint. Select the connecting rod and click the Duplicate Parts button. Rotate it by 90 degrees. Select two circular edges and apply circular edge constraint. Move the connecting rod to appropriate position. Change the increment to 1 and move the parts. Do the same for the other connecting rod. Add another part support. Rotate it by 90 degrees. Select these two circles as indicated and apply circular edge constraint. Then select these two circles and apply axis coincident constraint. Add the bushing. Rotate it by 90 degrees. Select these two circles and apply circular edge constraint. Add the pin. Select these two circles and apply circular edge constraint. Save and close the file. We open it to update the file name in the system. As in my other A2Plus video, I just create a simple macro to do the animation. Select macro and create a new macro file. Select View and open the Python console. Select the view, go to Edit, and send to Python console. Copy these two lines to the macro. The first line is to get the document. The second line is to get the object. This line is to create a counter and set it as a 0. The macro will run while the counter is smaller than 20. Go to the property of the view. The x-axis is -1. Line number 6 is to define the axis for rotation, so it is -1, 0, 0. Line number 7 is to increase the angle by 0.2 radian. It is about 11 degrees. The next line is to increase the counter by 1. Go to the FreeCAD file. Select the view and change the angle to 40 degrees. Click the soft constraint button to move all the parts to appropriate position. And we can find the corresponding Python code in the Python console. Copy and paste it in the macro. The last line is just to update all the windows in FreeCAD. Change the counter to 10 as the animation is very slow. Go to the FreeCAD file. Run the macro. The system is complex and the speed is really slow. That is why I run the macro with only one connecting wall assembly. Another thing to notice is that the angle increases by about 1 degree every time. The increment in the macro is about 11 degrees, but when we resolve the constraint, it will move the wheel too, so the net change in the angle is only about 1 degree. See the angle under placement. The macro is ended. Close the Python console. Select the supporting devices and click the Duplicate Parts button. Select these two circles and apply circular edge constraint. For these two circular edges, apply axis coincident constraint. Select the pin and duplicate the parts. Select these two circles and apply circular edge constraint. The assembly for this side is completed. Click the Move under Constraint button and move the wheel. Two connecting rods will move, but the response is very slow. Import the parts for the other side. Add the rod. Rotate it by 90 degrees. Select these two surfaces and apply paint coincident constraint. For these two circular edges, apply axis coincident constraint. Select these parts and duplicate. Rotate it by 90 degrees. Select these two surfaces and apply paint coincident constraint. For these two circular edges, apply axis coincident constraint. At the triangular part, rotate it 90 degrees. Select two circular edges and apply circular edge constraint. Import the parts short link. Rotate it by 90 degrees. Select these two circles and then apply circular edge constraint. Rotate the link a little bit so all the parts will move in the preferred direction. For these two circular edges, apply axis coincident constraint. The response is slow because you need to move the rock, the link, the triangular part, and the shaft, and also the crank, the connecting rods at the other side. Take the link and duplicate the parts. Do the same to connect the triangular part and the piston rod. Import the last item, the long link. Rotate it by 90 degrees. For these two circular edges, apply axis coincident constraint. Select two circular edges and apply circular edge constraint. Basically, the assembly is complete. Just need to turn around and duplicate the link again. Select the part and duplicate. Create the circular edge constraint at one end and apply axis coincident constraint at the other end. And the end with axis coincident constraint will allow some tolerance along the axis. Repeat the process for other short link. Again, it is really slow. Select the long link as the last part for the assembly. Repeat the process and create constraints at both ends. Finally, the assembly is completed. Click the Move Under Constraint button and select the wheel. Rotate the wheel could move all the parts, but the response is very slow. A2Plus is really straightforward for assembling parts, but for animation, the response is quite slow when the construction is complex. You can see the angle under placement is changing, but very slow. By Assembly4, the animation will be smoother. As Assembly4 is not working with constraints, we need to create a mechanism, attach the parts and the mechanism together, and use Expression Engine to move the parts. Please follow the link at the end screen to watch the full video of Steam Engine animation by Assembly4. If you found this video interesting, please subscribe and give it a like. Thank you for watching.